Welcome to Linacs Actuator Academy video series for industrial actuators. I'm Hunter, and today we're going to talk about the Actuator Connect configurator that Linac offers to their range of actuators with an integrated controller. I'll demonstrate how to connect the actuator to my PC and showcase some of the features Actuator Connect offers. The actuator used in this video is an LA36 with I/O interface, providing many advanced capabilities. Let's start by opening the program. Since it's the first time using it, it'll guide me through some of the benefits and how to get started. With this actuator type, you can choose between a wired USB connection or a wireless connection via Bluetooth. We're going to start by applying either 24 volts or 48 volt power to the actuator. You'll want to check voltage on the product label first. After this, we'll connect the USB cable to the signal cable input of the actuator. A few seconds will pass before the connection to the Actuator Connect is established and the actuator is ready for configuration. For Bluetooth connection, the I/O actuator can be equipped with an LED, which is used to identify the actuator that is connected to the PC. This is especially useful if you have several actuators nearby that have factory naming, like we see on the screen here. Now that we've connected our actuator, let's use the program. The first thing you'll encounter when you're connected to an actuator is actuator information, which gives you all kinds of relevant information about the actuator, similar to what you would normally find on the product label. As you can see, it tells us that we've connected our LA36 with an I/O basic interface. Because Linac knows that not every project demands the full range of I/O options, you get a choice of 3 levels of functionality: basic, full, and customized. For this basic version, you can see a lock on some of the features. You can still explore all these features, but it won't be possible to apply them to the actuator. If you want to access all features, it's possible to upgrade to the full version directly from Actuator Connect. Simply contact your local Linac office and inform them about the work order number of the actuator, and they can generate a key to unlock these features. I'm going to upgrade the actuator by clicking on the upgrade button and then apply the key. Now when we go back to actuator information, you can see that we have the I/O full version. In addition to that, you can see the actual wiring diagram of the connected actuator. This is important because I/O actuators offer various inputs and output wiring possibilities. The functionality of these inputs and outputs can be customized directly in Actuator Connect, and the wiring diagram will continuously be updated. A total of 6 wires can be customized. Some of the wires are reserved for a specific functionality and cannot be changed. Another feature worth mentioning in the Home section is the Save Configuration feature. This is especially smart if you're testing various features on a prototype and would like to make a backup of the configuration. Also, for parallel systems, this can save you time by avoiding the need to configure each feature on all the actuators. Now that we've reviewed the overall actuator information, let's take a look at the control bar in Actuator Connect. The actuator can be controlled from within Actuator Connect using buttons at the bottom of the screen, which are always available when connected. This can be especially relevant for testing or prototyping. You can run the actuator completely inwards or outwards with a single press of the run in or run out buttons. The actuator will either run to the physical end of stroke or to a preset virtual limit. You also have the ability to step in or out. Here I'm setting the step out distance to 10 millimeters. Now it's only going to move out by that amount. This can make mounting a lot easier if you, for instance, mount it with a bolt and need to align bracket and actuator. Another control feature is run to target. Here the actuator will move to a position of your choice, which can be set in millimeters. Use this to experiment with a virtual limit before applying these settings in the actuator permanently. In the bottom left corner, you have easy access to real-time data. This will show how much current the actuator consumes, actual speed, temperature, and position. You can also see the supplied voltage, which could indicate if the power supply is stable, even when the actuator is operated at full load. With this I/O actuator, Linac has developed many advanced software features that go beyond being able to set speed or current limits. Let's take a look at those now. Once connected, you'll be able to click on the 6 options in the left menu bar. All of these offer various configuration possibilities, and some also offer the ability to read out data. Let's go through them one at a time. The first option we have in the left menu bar is Adjust Movement. With this option, Linac ensures that you get full flexibility with various control options, virtual limits, and adjustable speed. Under Control and Adjust, you can see different control options for the actuator movement depending on your preferences. You can customize the speed settings for each of these options here. Virtual limits can be used to stop the actuator before it reaches the physical end stop. These can be set either manually in each direction by utilizing Learn Mode, where the actuator sets automatically a virtual limit based on a physical obstruction. The next option we have on our left menu is Position Feedback. Position feedback is important if you want precise overview of the actuator's position, which is performance critical in most applications. The actuator position can be read out in either a digital or analog output. Analog output offers the choice between current in milliamps or voltage in volts feedback. It's also possible to customize the range for the output signals to make it easier to integrate into your controller. Digital output is divided into two outputs, each having their own wire to offer flexibility. As an example, these digital outputs can be used to indicate when the actuator has reached the end stops, or as Hall pulses for pulse-based position readout. Please note that if a specific wire is already in use, then this banner will pop up. Protection helps you prevent damage and breakdowns by protecting your application from improper use. Under Current Limited, the I/O actuator has a predefined current limit, which cuts off power to the motor if this limit is reached. Here, you can set specific current limits in both directions. If you want customized current limits throughout the stroke length, then you can set 10 variable limits in each direction, each at a 10% interval. Start settings and stop settings allow you to gradually increase or decrease the speed of the actuator when starting and stopping movement. This will extend the service life of the actuator and reduce stress on the mechanics of your application. In some cases, there may be external factors that need to be in place before the actuator can run. You can use the third digital input as an external precondition to allow movement, either as a protection measure or to reduce complexity in your controller. As an example, this could be a rain sensor that prohibits actuator movement when it's raining. The sleep mode functionality is developed for battery-powered applications where the actuator can go to sleep when not in use. This will reduce standby power consumption by up to 90%. Monitor can provide real-time and historic usage data for useful insights. The data can be used to learn details of the actuator performance in your application. With the real-time view, we're going to go ahead and do a step out of 100 millimeters and see what information we can get from the actuator. Let's look at the current consumption during the 100 millimeter movement. Here we have the option to take a snapshot. You can use this information to see if you're experiencing a change in the load over the stroke length. Just like we offer real-time charts, you can get real-time information about the actuator's power consumption and temperature via an analog or digital signal directly to your PLC. From the first time your actuator powers on, usage data is collected and stored internally throughout the actuator lifetime. This historical data can be read out and provides in-depth insight about performance over time. It's possible to download a complete report as a PDF with general information about the actuator and comprehensive usage data that summarizes all stored historical data over the entire lifespan of the actuator. Use this to analyze the performance of one actuator or compare several actuators. The PDF also contains a wiring diagram and software configuration details, which can be used if you want to order new actuators or simply as a starting point for a technical discussion with your local Linac contact. Diagnostics can help you avoid unnecessary downtime of your application and guide you through troubleshooting. Under Current Status, you can see the status of the connected actuator and get remedies and solutions to solve a potential issue. Under Error Log, if the actuator encounters an error, it is possible to identify the exact cause that has triggered a stop. The actuator logs the last 5 errors it has encountered as well as their frequency. This is documented with a timestamp that can be compared with the total actuator running time. The I/O actuator can be equipped with a transparent connector and an LED. This enables fast diagnostics by simple visual inspection. When the actuator is fully operational, the LED will be green. If the color of the LED changes, it might indicate an actuator malfunction. On this next menu, several error codes can be read out on the digital output. During a 10-second time frame, the actuator will send a number of pulses to your controller, depending on the error type. With an I/O actuator, it's also possible to run multiple actuators in parallel, even if originally set up as a single actuator. Regardless of any variations in load, the actuators stay precisely aligned when moving, and the master will always ensure that the followers are present in the system. When selected, you can choose the number of actuators in the parallel system. It's important that all actuators in the parallel system have the same configuration across all features to ensure that the system works as intended. To make this process easier, you can copy the configuration from one actuator to the others by using Actuator Connect's Copy Your Configuration feature. We're regularly adding new features to our I/O actuators and Actuator Connect configurator, so be sure to sign up for our Actuator Connect newsletter to get relevant news, software updates, and tips and tricks. Also be sure to check out the Actuator Connect page at Linac.com. There you'll find more information, this Actuator Connect video guide, how we set it up, how to connect it in a step-by-step process as we talked about in this video. It's also possible to find an Actuator Academy video for each of the options we just discussed. We hope you enjoyed this introduction to Linac's Actuator Connect configurator, the features it offers, and the behaviors behind them. If you have any questions about the configurator, feel free to contact your local Linac office. Thanks for watching.